สวัสดีครับ
Hello everyone, we are from Jidara School.
My name is Nayo Suwatano.
My name is Purivat Wanawanitya.
And my name is Panakon Kritom.
Today we are going to talk about the effect of water hardness on eatable water bubbles. Plastic waste is one of the problems the world is facing right now. From the graph, you can see that the amount of plastic waste has increased significantly over the year. So, there was a research about substitute for water bottles, the water bubbles, which may aim to reduce the amount of plastic waste caught each year. Our aim was to research if there are other factors that can affect the water bubbles. In this research, we aim to study on the water hardness. As you might know, the water hardness is usually determined by the amount of calcium ion and magnesium ion dissolved in water. There are 4 levels of water hardness, including soft, moderately hard, hard, and very hard. However, the hardness of drinking water should not exceed 100 mg per liter, or you could say that it's likely to be at a soft level. Let's see why water hardness is important to our research. The water bubbles are formed by the solidification reaction, the reaction that happens from sodium alginate and calcium lactate to make calcium alginate, which is the sophia for water bubbles. By that, the reaction is affected by the amount of calcium salt in water. In hypothesis, reaching the amount of calcium salt will make the reaction to produce more calcium alginate. So, the purpose of our research is to study about the correlation between water hardness before and after the verification reaction, and to study the optimal hardness of water to be used in the making of water bubbles. So, we divide experiment set into 5 groups: poor water and hard water, which is 25 and 50 mg per liter, and 2 mineral waters which contain 26 and 80 mg of calcium salt per liter. In 25 and 50 mg per liter hard water set, we will use calcium chloride as a calcium salt because it is usually used in food manufacture.
For an experiment method, first we mix 1 liter of distilled water with 25 mg of calcium salt to make hard water, and add 6 grams of sodium alginate to it. Then we mix 6 grams of calcium chloride with 250 ml of distilled water. After that, we freeze 50 ml of sodium alginate solution in 5 degrees Celsius, freeze for 2 hours. When substance was frozen, we soaked it in calcium lactate for 10 minutes to obtain water bubbles. Finally, rest water bubbles in distilled water for 10 minutes to make the ice inside melt completely. After the first set, we repeat the same process but differ in amount of calcium salt. As you know, 0, 26, 50, and 80 mg per liter.
After the experiment, the bubbles were analyzed under the following 2 topics. First, correlation between the hardness level of water before and after the reaction. As you can see in the table, it turns out that hardness level of water remained the same. Second, we are looking on the strength of the water bubbles. We use the texture analyzer machine to determine the force that water bubble can withstand before it breaks. This bar graph illustrates the water bubble strength and the water hardness. The water bubbles that were made from pure water with 25, 26, 50, and 80 mg per liter of calcium salt can withstand the force at 1.509, 1.648, 1.78, 1.804, and 4.191 Newton, respectively. To conclude, it can be said in the production that the harder the water is, the stronger the bubbles. This video shows the texture analyzer machine. And here is our reference. Finally, we would like to thank Dr. Bongkot Hararak, the researcher at National Metal and Material Technology Center, Bangkok, for her advice and permission to use the lab at NSTDA. Thank you very much for your attention. See you in the Q&A section. For now, goodbye.